and welcome all to the third installment of the August series webinar by me, Michael Studdert. If this is your first one here, I've been at One Spatial for about 5.5 years now and started using FME here, and has basically been the encompass of my time in the spatial industry. So yeah, pretty fresh. And today's webinar is on identifying vulnerable residents for evacuation, one of the use cases that I got to cut my teeth on over in the UK last year. Just quickly, the agenda today, we'll talk about the risk and vulnerable residents and essentially the use case of the presentation, then how we create the evacuation report and outputs in FME, then go look at the results and how this can then be further expanded into other things as well. So risks and vulnerable residents. So there's a range of things that can happen that require everyone to evacuate and leave. Maybe not something that's quite as intense in the photo to the right, but knowing the vulnerable residents, a part of that, is very beneficial if we need to find that out very quickly. And the vulnerable residents is really just UK's way of identifying people that are going to require extra assistance if they needed to be evacuated. And this usually is it's usually the disabled and the elderly make up a big chunk of that. This was an example over there from when I was there. I think it was at the start of the year, it might have been late 2023, but essentially they found a bomb from World War II somewhere in Plymouth, and they took it out to sea and blew it up. And they had to evacuate a lot of people that were along the bomb disposal route, obviously, if worse came to worse. So this is this is what I based my use case around, and I'll show you a little bit how I did it. The solution would be to create an evacuation zone using FME and using the event of interest as the basis for that. So I did that by bringing the building footprints and address data that I can get from Ordnance Survey over there. And the vulnerable residents, they have a UPRN system which identifies residency addresses. And I'll show you in a bit, but then just used FME to sort of dummy up some vulnerable residents across the study area. And using those address points, I conflated those onto the building footprints, so we know which buildings are going to be affected when by the event. And that's just done by using a buffer on the route as the clipper to identify the affected buildings and therefore the vulnerable residents in it. Because you'll see this soon in the output, but the logic is that if the building is within the clip, the whole building is included, because there's not much detached housing over there in the main areas. So you'll have multiple residencies in the one building. And then we can provide that in a report, in a CSV, and then a shapefile as well. This is the FME workflow that gets the job done. Sorry for the blurriness. Definitely a plug to try and get an export to PDF or something similar. But anyway, I'll take you through just the different components of the workspace. So the top is combining the address points as they get delivered to you in sections. So just bringing those together for the entire sample space. Then these are the building polygons that just need to be filtered to get the polygons of interest. The next one's creating the buffer zone down the bottom, sorry. And then we're sort of bringing this all together in the middle and then writing it out to the GIS file, and then also doing a little bit of manipulation to get a CSV report at the end as well. This was the workspace, just quickly showing you of how I got the vulnerable residents. Really just simple process of putting all the address points together and then just using here the sampler to filter out 1 in 6, so 15% of them. Probably should be more than that, to be honest, and then assigning it as a yes and then no, bring them back together on the same attribute, and then writing it out to the spreadsheet, which I showed you in as a reader in the workspace before. So finding buildings with vulnerable residents, this involved using the code from the codes list that categorize buildings in the area layer, because there's other features such as parks and vegetation in there that we're not looking at. With the disposal route down the bottom, we run that through a reprojector and then just buffer it to 150 meters, which is what we used in the use case here, but that can realistically be applied to anything or can change if you need it to. And then what we're doing is using a counter on the area. We're going to clip the buffer on the buildings. So we've got the buildings of interest that are going to be affected by the evacuation. But what we're doing is, because we've applied the counter as an ID before, we can actually merge the buildings back on to the ones that have been clipped out by the clipper, because the geometry, it will actually cut off the building, and that's not quite accurate. So you merge back on the geometry that has been unclipped, and you'll have a full building that's being affected by the buffer zone. The process of conflating the vulnerable residents' address points onto the buildings. So for processing time, we've filtered down the vulnerable residents' address points and the affected buildings, so we're not conflating whole data sets onto whole data sets. Then part of that conflation process, as you can see on the right in the image, is generating a list of the UPRNs. So we can have each building have the UPRNs of vulnerable residents that are affected on it, and that can just be then concatenated out and have that as an attribute. And we can also use the number of suppliers output to actually tell how many vulnerable residents are living in, how many vulnerable residents are in the building. And then we'll filter the data according to that later on for mapping and reporting. And this is what the output looks like. So with that route that's in the red in the middle, you can see it's created the buffer zone in cyan around it. And we've got the orange buildings, which are non-vulnerable people homes. You can see there the big chunks on the left. That could be an apartment block, but it's probably just industry or something like that. And the dark blue are the vulnerable people homes. The buildings, I should probably say, and the yellow points are all the vulnerable addresses that are affected. So you can see there's only a couple in there that don't have any vulnerable residents. So it's quite a good tool for this particular use case. So the vulnerable resident CSV report, it's pretty straightforward. What we're doing is just because what we've got to do essentially is turn it from buildings into people, because we want to know a list of all the vulnerable residents that are affected as opposed to the buildings. So we do that by splitting the attribute using the delimiter values which is the comma in this case. And then from there, we explode the list, because this attribute splitter turns into a list, and then the list exploder turns each one of those values into its own feature. So that you can see it's gone from 97 to 303. So there's roughly about 3 vulnerable residents per building. Then that gets merged on with the original UPRN data to complete the information, and then just cleaned up and attribute managed, and then written out into a CSV file, which looks like this, just viewed in the FME viewer, because it's going to look the same in Excel, but at least we can get a bit of a graphical view on the right there too. So further use cases. So this is where it gets a bit more interesting. There's a lot of potential to use this framework for other events and evacuation notifications. As I've sort of alluded to before, the route there was used for a bomb evacuation, but you could use it for other shape files or events that just require not so much the evacuation of vulnerable residents, but more so just a notification too. Like if there's flooding, it might have to be, well, that would probably be evacuation, to be honest, but road closures and things like that, it's just more or less letting them know, because access to bus stations or various things might be dependent for them, and those things might be affected. And you could also put in there assessing voting booth locations within the various voting wards as well, because obviously the vulnerable people still have to vote, but getting there is something that has to be addressed. A universal solution for all of these use cases with just a bit of fiddling and a change of parameters is to create a portal using web apps in FME Flow. So we have the bomb evacuation workflow as a base, and we go through and make some changes and some parameterization to then fit the different use cases. In this particular use case, we would be replacing the bomb disposal route with any sort of situation that this is applicable for a shapefile that does or does not need a buffer distance, which we can change if required. And the output we're going to get from this is a shapefile of all the vulnerable residents and buildings that it impacts, along with a CSV report as well. And now I'll just take you through a quick recording that I made of this use case in effect in FME Flow. Okay, so what I'll do now is I'll show you live the web app working. So I've just got up the previous result here in QGIS where we had the disposal route go through and had to evacuate the vulnerable residents around it. Now I'm going to be adding in a different path shown here in red that could be more of like a parade or a road closure of the main road going down to the beachfront in Devonport. So this is the web app. I've just put a little image in there, but you can see it's the same user parameters as before. But what I'm going to be doing is I'm dropping in the custom path as opposed to the other one. So that's what's just popped up, and we'll click that and it'll run. So while it runs, I'll show you behind the scenes in the web app what's going on and how this is all sort of working. So there's the map file. Those are the user parameters that we just saw then, and I've got ticked to show in the app. That links to the workspace. But the user parameters that are in the workspace that's not showing up in the app are all the files that I'm reading in that don't need to be touched. They're always from the same source, so it's never going to change with any type of request. And then the really key part is that when you publish this to FME Flow and then you link the workspace to the web app, it still has the same file path as when you were making the workspace in FME form. So you have to go in and change the resources or the source file to where it sits in FME Flow, as opposed to the same local file path that it has when you uploaded it. So when you're publishing it, just make sure that you publish upload the data as well and put it in a folder you can find. And it should be pretty easy to link and to get going. Have we had it's still running, so might just be another couple of seconds. But I guess there's some other sort of customizations you can do. I guess you can put in some browser icons as well, so that will change what pops up in there. So if I put it in again and upload it, yeah, that's fine. So we can set that as the icon and we'll save it. Leave it there. Okay, so it's done now. We'll have a look and I'll open it up and we'll just extract that. So what we should be seeing is the map that we just saw before, but then we should also see the other feature writer that has the CSV report. So that's the output there. And then we've got the feature writer here that I've still left it on the old naming. But then, so if we drop it in, now we can see that it's got the same sort of thing, but just for the different path. So, yeah. I'll take you through a few examples now of how this can be used for other things as well. So if we replace that with, say, flood lines, we can use the buffer to then go find the vulnerable residents that need to be notified. And this is a bit of a zoom in on one of the more crowded parts, so you can see how it's gone in and cut around and included some of the buildings that would have been sawn off, but are now included in the analysis. Road closures. So if we reconfigure the filtering process and the user parameter influence and change that to selecting a road name as opposed to contributing your own source, then that road name and segment will be filtered out, and then all the other road segments are spatially related on to find which ones touch that road, and they become the source and to be buffered and collect the vulnerable residents that are affected. And this is just a bit of a clip up of the results. So you can see in the app, it's just pretty much the same, but we're just changing the road under construction and taking out a file to contribute. And then that will filter out and we get that road in the red running down the middle and the pink buffers that have got the road segments that are touching, with the logic that if they're in segments, it's probably in access. So it might not be necessary to notify the entire length of the road over it because it might not be as impactful as to others. Another part you can add to the workspace that I've done is by creating some analysis figures by just creating essentially the total residents and number of buildings for both categories of residents. And that was essentially done by just creating outputs that isolated the affected non-vulnerable, so having 4 outputs in total, then creating a status attribute and assigning vulnerable and non-vulnerable to the appropriate ones, and then aggregating according to the status. And it gives you just that little snippet that can be quite helpful for people. And I also added a little part too, where if we use the merger to validate any, because essentially this validates that there's no matching UPRNs across the vulnerable and non-vulnerable, so make sure the data is clean, and anything that merged we can put into a terminator and cancel the process, so it'll stop the web app from running from whoever's submitting into it. Another use case, the polling booth proximity one, using the Devonport ward as our study area. So we've got the wards here that go across the UK, focused on the same area we've been using throughout the presentation, which the Devonport ward is in the middle of that blue box, and you have the voting booth locations across that have been sourced from the Democracy Council. So I've done an analysis on Devonport, and that is available in this web app as a user parameter, which then acts as a clip for the rest of the data and isolates just the polling booths associated with that ward, and then continues on the rest of the analysis. And the results come out like this. So I honestly thought there would probably be more if there's 2 voting booths right next to each other, but there's a handful of vulnerable residents in the pink dots there, but it's sort of just non-residential buildings that mostly take up that radius, which I used a 1.5 kilometer radius for. So probably a bit better logic that suits that particular use case as well. I use that use case just now about the voting booths as the foundation, or the use case to try and take this from a workspace that has a lot of flat files, uses a lot of clippers, as I've shown you, and makes it a bit more production, like more of the people in the audience, if they were going to use or build something like what I'm showing. So I want to configure it to run more efficiently and use systems that would be used in a production environment. And I was able to achieve this with spatial filters that are used on feature readers. And that process alone cut it down the transformer count from 31 to 23. And I'm just going to show you now one of those feature readers here. And it has the Oracle database connection up top with the spatial one, and the relational ones I find bring in the attribute values better. And then you can see it's reading in the table, which is the vulnerable residents, and the clip is then the clip ward is the initiator. So we just want the results that are contained within that initiator to come out. So this is a bigger view of the selection of the ward that uses the clip for the feature readers. So you can see it gets read in and then reprojected, so the clip works properly because it was playing up a lot before. And this part in particular is where all of it sort of happens. So the parameter fetcher is essentially offering a choice to the user of the 5. I've put in, you could do the whole thing if you wanted, but I put in just the 5 wards that were closest to our study area. And what it will do is you put in whatever the choice is, the parameter fetcher will then assign that value, that selection, to the target ward attribute, and that assigns it to every single feature. However, when you combine it with a test filter on the right, it will match up the selection that you put, because there's only going to be one feature that will have both the selection you want and its actual name. So as we just find that one feature that has that match, or if it has multiple selections, it could be multiple clippers as well. And then that's what goes in to filter out the different features in the feature reader. And then finally, this is what the entire workspace now looks like. And it really hasn't changed a whole lot other than really the top one here I've got in the yellow box, which is just taking the two database connections and merging them to find out affected which GPNs have vulnerable residents and which don't. So yeah, saving a lot of time there and making this a bit more production friendly. And that's everything. So appreciate you coming along to the webinar. Hopefully it was engaging and got a bit of value out of it. I'll pass it back to Daniela now and we'll read out some of the questions that have come through.